Here's the next question, number 24. The graph associated with an electrical network has 7 branches and 5 nodes. The number of independent KCL equations and the number of independent KVL equations respectively are. Okay, so since they're talking about a graph, let's just assume a certain graph. So it says that there are 7 branches and 5 nodes. So in general, I'm just going to put down 5 nodes here. 1, 2, 3, 4 and 5. We have 5 nodes here. And the graph has got 7 branches. So let's see, that's 1, 2, 3, 4, 5, 6 and 7. Okay, so here are the 7 branches. So this is just, you can draw any kind of connections, give the connections as you wish, but in general I have put it down this way. And so we need to find out the number of KCL equations and KVL equations. So for current, it depends on the number of nodes that are there. So here, if we were to consider the 5th node as a base or a reference, so that would give us 4 different KCL equations. So KCL would be equal to 4. So that's 1 less than the total number of nodes that are there. So this is just an example. I'm not giving you a standard formula yet. I'm just explaining in terms of a random example. So we have 5 nodes. I've drawn a random graph here. So for which, if we were to find out the number of current equations, so those would be 4. And the number of voltage equations deal with the number of loops that are there in the graph. So here we see that there are 3 loops. That's 1, that's 2, and that's 3. So that's 3 loops. So the number of loops will give us the number of voltage equations. And the number of nodes would give us the number of current equations. And the number of nodes, the total number of nodes are 5. But then if we were to assume 1 as a ground node or a reference node, then the rest would correspond to the number of current equations. So I hope that makes sense. So now I'm going to give you the formula based on how to solve if you get something like this in the exam. So the number of KCL equations, okay, the formula is n minus 1. The total number of nodes minus 1. So in this case here, the total number of nodes 5. 5 minus 1 equals 4. So we have 4 KCL equations. And then comes KVL equations. Kirchhoff's voltage law equations. And Kirchhoff's voltage law corresponds to the number of loops in the graph. So based on what's given to us, the formula is B minus n plus 1. B minus n plus 1 is the number of loops. So the branches are 7 minus the number of nodes 5 plus 1. That gives us 3. Okay. So the number of KCL equations 4, the number of KVL equations are 3, and that corresponds to the option D. So it will do good to remember these formulas here, n minus 1 and B minus n plus 1. I hope this has helped.